electronics, also the B in electrical engineering. He is currently serving as an associate professor at Gokhale Education Society's R.H. Sapat College of Engineering, Nasik since July 25, 2017. Prior to this, he held notable position as an associate professor at Symbiosis University of Applied Science, Indore, and as a faculty member of various institutions such as SVC, IES, IPS Academy, and SGS ITS in Indore. He has 90, he has 40 publications in reputed national and international journals, conference and book chapters. Dr. A.S. Koshti sir serves a reviewer for multiple journals, including International Journal of Electrical Power and Energy System, IET Generation, Transmission and Distribution, Institution of Engineering, India. Dr. A.S. Koshti sir is a member of Institution of Engineering, India, holding a membership since March 31, 2016. His outstanding contributions have earned him several prestigious awards, including the Ministry of Energy Department of Power Prize Certificate with Gold Medal for the best paper in the Journal of Institution of Engineering in December 2013. He has also received the Pandit Madan Mohan Malviya Memorable Prize certificate with gold medal for the best paper in December 2015. Throughout his academic journey, Dr. A.S. Koshti sir has demonstrated a commitment to excellence in teaching, research, and monitoring the student. His work and dedication continue to inspire both staff and students in the field of electrical engineering. Today, Sir is sharing knowledge on the topic optimization of techniques. I request Dr. A.S. Koshti sir to start the session. Over to you, sir.
Thank you, madam. And I would like to give my basically, I am thankful to the management and society, Professor Rane and Principal Professor Deshpande madam for inviting me for this FDP. Basically, I am going to tell you something about the optimization technique, basically meta heuristic optimization technique. And one of the technique like genetic algorithm, I am going to demonstrate some examples so that you will be able to understand it and then you can use it. Let me share my PPT. Right. Can you see the screen?
Yes, sir. Your screen is visible.
PPT is visible?
No, sir.
No, no, sir. PPT is not visible.
I think
Yes,
now
yes. Your PPT is visible now.
okay. See, basically, I am going to tell you something about the optimization problem. In electrical engineering, also there are a number of problems that basically we can optimize and we can get the solution for basically any optimization problem. If you see, then it is expressed as a function. So basically, we have to see a kind of uh, any kind of maximization or the minimization problem. It is to be represented by function. So the various examples are there. Like we can take the easiest example, that maximum power transfer theorem. I think all of we are aware with this kind of theorem, maximum power transfer theorem, where our objective is to transfer the maximum power to the load. So this is a kind of maximization problem. Okay. So basically, it is also a function. Basically, it's function of some variables, and then it's a maximization problem, and there may be a kind of minimization problem, minimization of function. You can take the examples like power loss minimization in transmission line. You can see that there may be a transmission system or maybe a transmission system, maybe radial system, where basically our objective is to minimize, say, the power loss, total power loss, real power loss, or maybe reactive power loss. So that we can take as minimization problem. Also, we can take the problem of the economic load dispatch where we have to minimize the cost. So it is a minimization. So basically, when I say an optimization problem, then that optimization problem will be represented by a function first. That function is a function of some particular variable, maybe 1, 2, 3, or maybe n variables. So that particular function may basically it may be a constraint optimization problem or say unconstrained optimization problem. When I say constraint optimization problem, it means we are having certain constraints. It means suppose if I take the example of say maximum power transfer theorem. So what is our objective? We change basically the load resistance, and then we want to find out what is the maximum power which is consumed by that particular load. So there we can take the load resistance as a control variable, and that resistance basically, if you we cannot put it say the minimum resistance. So their value will be from it is from 0 onwards. It's a positive number, the positive resistance. So it is called as the constraint. So basically, most of the types of problems what we have in practical life, they are constraint optimization problem. And second way, the unconstrained optimization. If suppose this same problem, maximum power transfer theorem, if I take, if there is no bound on the say value of resistance, so it can take say the any value from say in any feasible space. Uh, so then it will become the unconstrained problem. If there is no constraint on the value of r, it should be greater than 0. So if I don't put any constraint on that, then it is called as the unconstrained optimization. So basically, when I say constraint optimization problem, then you can see your x, basically control variable, set of control variables. It is called as the control vector. Basically, for an optimization problem, it may be function of say n variable. If you are having n control variables in your optimization problem, then the size of your control vector or design vector, it should be n. You can see here, find x is equal to x1, x2, xn. So these are nothing but the control variables. With the help of that control variables, we will be able to optimize the function say f of x. Our objective is to minimize this f of x, maybe minimization or maximization. So this function we want to minimize here with the help of this is function of n variables x1 to xn, and they are subjected to say the constraint. Here you can see g of j x is less than or equal to 0. There you can have say m constraint. So this particular equation is called as the inequality constraint. Inequality constraint. Just below that, if L of j of x is equal to 0, suppose you are having t equations, j is equal to 1 to the t. So these equations, they are called as the equality constraint. So for an optimization problem, basically when we optimize any function, it means we are to optimize control variables. And those control variables, basically it must follow these two constraints, the equality constraint and inequality constraint and equality constraint. Am I clear to everybody?
Yes.
Say we have to make this session interactive so that whatever things I am telling you, just reply whether it is coming to you or not.
Yes,
It
sir.
is
Yes,
coming
sir.
Yes.
to
Yes, sir.
okay, okay. And then basically, if you take say one example I have given here uh, to understand what is an optimization problem. it's a very simple circuit, the same maximum power transfer theorem. There you can see one DC source is there to a Thevenin resistance, maybe a source resistance, or say there is we have a load resistance, and that load resistance is basically variable. So if I want to express the expression for the power, then based on the current and voltage, you can see here the equation P is equal to I square into RL. If you have this equation, this is an optimization function basically. And what is your objective? We want to maximize this power P with respect to the control variable. Which variable we are going to take as a control variable? Load resistance, as it is variable. Other parameters, say VTH and RTH, it is fixed. Maybe source voltage or say source resistance, it is also called. So basically, when you see this optimization problem, so if you say take the first order derivative for this power, then you will get that condition. If you differentiate the power with respect to load resistance as it is variable, and if you are going to put it equal to 0, so then you are going to get the condition RL it is equal to RT. This this is also an optimization problem, and it is this optimization problem is basically based on the derivative. This derivative we have evaluated. In some kind of problems we have to find out the second order differentiation also, and then we have to equate it to 0. Then we will get the equation. This is a kind of conventional optimization problem. There are certain drawbacks of the conventional optimization problem that we cannot solve for a kind of problem, maybe a non-convex type of problem. Basically, where you can see if you plot the curve for P with respect to load resistance, then you are going to get this kind of curve. Okay. So this kind of problem, basically, when you see there is only one maximum value of power. This is called as the convex type of problem, convex type of optimization problem, where there is only one maxima or say minima. For the maximization problem, you will have only one maxima value, and for the minimization problem, then you will have only one solution. Uh, so here I am going to take this as the optimization problem, and then control variables I am going to select as load resistance. So just it's an example. I am telling you what is about optimization problem. So there are so many problems in our electrical engineering also. Say for example, when you are going to calculate the efficiency of a transformer, uh, I think all of you are belongs to electrical engineering, or there is anybody who doesn't belong to the electrical engineering? Is there anybody? I think all belongs to the electrical engineering, so they will understood it well. Transformer efficiency, when I plot with respect to the load current, then also there is an you can see the maximum condition at some particular with respect to the loading condition. So that is also a kind of optimization problem you can say. So first of all, we must understand what is optimization problem, and then we will go for how to get the solution for this kind of optimization problem. Some traditional techniques are available, conventional techniques are available. They are going to give the solution. They are called as direct search methods, or maybe based on some derivative, maybe first order derivative or the second order derivative. But these methods, they are not suitable for discontinuous function. If your function is discontinuous or non-differential, or say having non-convex type of problems where there are many peaks available, where in this case for the maximum power you can see only one maximum power condition is available. But in practical scenario, most of the problems they belong to the non-convex type of problems where there are number of peaks for an optimization problem. So then these traditional techniques, they are not suitable for giving the solution. The another example, say in transmission line, I just taken from one of my PhD students. The work basically, they have worked on say the minimization problem in radial distribution system by putting the DG capacity. Nowadays, basically due to the restructuring, the deregulation basically in the radial distribution system also we are going to have the distributed generation. It means solar capacity. solar installation, solar plant installation, or maybe say wind power installation. So one problem we have taken that we have to minimize the real power losses with respect to some control variables. So you can see here the equation one power flow equation. It means whatever is your load demand, and basically we have to use some load flow technique in transmission system. Basically Newton Raphson method it is used for finding out the solution, but for radial distribution system basically maybe that methods are not suitable, they don't give the solution. So you can use forward and backward sweep method for finding out the quick solution. And here you can see the constant minimization of real power losses and with respect to some constraints. In power flow equation number one, it means whatever is the load demand is there into the system. So the summation of load demand plus summation of losses, it is equal to the supplied power. This equation should be followed. It is called as the power flow equation. Number one, it is called as the equality constraint equation. The line flow constraint, say for you have n number of lines, say nl lines you can say. For each line, there is certain limits that this line flow it should not exceed some value. So it is also known as some kind of inequality constraint. And the third is the DC capacity constraint. On say I am putting say a solar DC capacity in some limit, say 100 kilowatt of plant or say solar plant I want to install. So the limit from 0 to say 100 kilowatt, because you can see this DC capacity, the solar generation by that plant is also an stochastic variable. So I am going to take it in limits 0 to this. So I think for the minimization problem, for say the maximization problem, I think it's very clear to you what I mean to say by optimization problem and what I mean to say by constraint optimization problem. Uh, Now let us see unconstrained optimization. If again you will have some set of control variables where you have to we have to minimize say the function f of x or to maximize f of x. But if you don't have the limits on say individual of these control variables, then this problem I will call that as unconstrained optimization. I think it's clear to everybody what I mean by constraint optimization and unconstrained optimization. As I told you that traditional optimization method basically they are direct and gradient based method, direct search method basically. So you will see that direct search method kind of objective function is given and constant values are also defined. They are used to guide the search strategy. It means they are going to search the optimal solution based on this information. Number one, objective function is there, and then you are having constraint. And second, you are having some gradient based method. Gradient based methods, it means you have to find out say first order derivative or second order derivative of the objective function. Then this information will be used for us to fast or search the optimization value, optimized value you can say. So as I given the example of say the maximum power transfer theorem, where we are going to, we have taken some kind of derivative, first order derivative, and then we have obtained that equation. So you can see that this traditional optimization technique may be a direct search method or maybe a gradient based method. But basically gradient based methods also they also fail if your function is not differentiable or say discontinuous function if it is there objective function basically, then we cannot get the solution by traditional technique. These are the drawbacks of your traditional technique. So you can see this the common difficulties with the traditional optimization method. The conversion optimal solution depends on the given initial solution. Whatever initial values you have taken, based on that it is going to search, and based on some basically differentiation the derivatives basically. So with this kind of conventional or say the traditional optimization methods, they may get problem kind of stuck into an suboptimal solution. It means it is not going to get the converge in some cases, like the examples I have given, non-convex type, where there is a number of peaks in the objective function, or if the function is not differentiable, or say it's a discontinuous. So these are the some difficulties with the traditional techniques. Therefore, uh, and these are the some names of some traditional or say conventional optimization techniques based on gradient-based method, Newton's method, linear or say nonlinear programming method that you can use. The advantages also there are certain advantages that it may be converged fast, and basically these are suitable for convex type of problems, optimization problem. Convex, it means there is only one peak, either way in maxima or say minima. If I talk about minima, then there is only one value, you can say, only one solution. So they are best suitable for convex type of problems. But if you have the non-convex type of problems where there are many peaks or say many values, then it cannot be suitable. So then basically, which are the methods nowadays? There are many of the methods uh, known as the meta heuristic optimization technique. Basically, number of methods there are nowadays. There is a research is going on to develop some kind of new meta heuristic optimization techniques. Some of them are genetic algorithms, particle swarm optimization, anion colony, or say maybe differential evolution, particle swarm, teaching learning based optimization. So there you can see basically these all methods, they comes into category of meta heuristic optimization. They are basically dependent on some stochastic variables. The advantage with these methods are they will be able to find out the global optima instead of local optima, basically to a non-convex type of optimization problem. Global search capability, it is going to search the throughout of the whatever space is there, it is going to search. Then it can be used for complex problems, it can be used for non-linear problems, it can be used for non-differentiable functions and discontinuous functions. No gradient information is required for this kind of optimization problem. The restriction may be it may take some more computational time for solving, because depending on the algorithm, it is going to take much time. So maybe not computationally efficient, but in some of the cases, but they are going to give the solution for the things which I told you, that is about non-convex type of problem. Just wait. Now I am going to take one problem, basically, so that you will understand it. So today I am going to take one method, basically genetic algorithm, or say binary coded GA basically. There are the genetic algorithm, it is basically based on the natural genetics and natural selection. You can have the binary coded GA or say real coded GA. Usually you can see that for a problem, optimization problem, a function is there, and that function is basically a function of some particular variable, and that basically the control variables. We are going to represent that function with respect to the variables, and that variables basically we are going to represent it by binary strings. Let us say if I take a problem, just wait, sorry for disturbance. uh, yes, we have to take basically one optimization problem where let us say, let us consider a problem say sin of x. This it is a function sin of x, and x is a control variable, and the constraints are given that your x will be between 0 to pi radian. So you can see this variable bound, they are nothing but a kind of constraint on that variable, and we have to find out the maximum value of the sin of. So it's an optimization problem. So this optimization problem basically we are going to solve by an binary coded G. So this X basically we are going to represent by an binary string. Now the question arises, we have to represent a solution. Solution basically these are, it is nothing but a real number in between 0 to pi. So how to get that particular value? So there is one formula you can see here. Uh, X of I is equal to xi minimum plus xi max minus xi minimum upon 2 to the power L of I minus 1. Okay, and this is nothing but a decoded variable. Now first of all we have to identify each and everything. What is xi max and xi minimum? So you can see the x minimum value is given as a 0, and x max here it is given as 5. Because within this limit we have to generate the control variables basically. Basically these all techniques, they are work, they are on the basis of that we have to generate some population, and then we have to evaluate the objective function. Based on that, if your control variables they are within limit, if they are following constraints, maybe equality or inequality, then only we are going to put it for evaluating the objective function. So first of all, our objective is that we must get an initial population. So initial population, for finding out the initial population, is the first process, representing the solution. So for representing the solution, we have to use this formula. Now each and everything, xi max or say x maximum value is pi, x minimum is 0, and L of I is nothing but a string length used to represent, uh, you can see L of I, string length. String length. You can take say 4-bit string or say 5-bit string, uh, and then we have to evaluate the decoded value of the string. What I mean to say by decoded variable, let us say if I take say this 1005-bit string I am using here, basically, can you see this in green? It is highlighted in green. Just reply yes or no.
Yes, sir.
Okay, okay. Now what we are going to do, we have to generate initial population. Initial population, it means I am going to represent the x, that sign of x basically. X is nothing but control variable. That control variable we have to represent through binary string. That binary string, I am the length I am taking L of I is 5 bit. 5 bit I am taking to represent that solution. So L of I is now also, it is clear to you. I am taking L of I, L of I is equal to 5. So if you calculate this 2 to the power 5, it means 32, 32 minus 1. Then the denominator here, 2 to the power L of I, it will be equal to 31. Okay. And here in the numerator, what we are going to do, x max value it is pi minus xi minimum it is 0. यहाँ पर ये आता है, you will get pi. Xi minimum it's a 0. So if you see, then this function you will have 0 plus pi minus 0 upon 2 to the power 5, 32 minus 1, it's a 31 into decoded variable. Now the only thing is that decoded variable. Now if you want to
मोबाईल आणि
get the value
पी
of
सीवर
decoded variable, basically it's nothing but the decimal value of that string. You
मोबाईलवर
can see here,
नाही नाही
if I take
इथे खाली जाते कोणीतरी अजून एक आहे
this
ते पण उडवून दिसतंय
decoded variable
खाली ना
5 answer ना
5 bit string.
हे
So
दोन
then
ठिकाणी झाले
the
असेल पी
decimal
सीवर आणि
value of the
मोबाईलवर
decoded value you are going to get 16. Yes or no?
चांगले ना तेवढे जास्त दिसतात
कैसे करते हैं ये? Hmm? How we are going to do it? Now let me explain you this process. 2 to the power 4 into 1 plus 2 to the power 3 into 0, 2 to the power 2 into 0 plus 2 to the power 1 into 0 plus 2 to the power 0 into 0. Basically, you can see string what we have here. Say 1, 0, 0, 0, and 0. Okay. So this type of thing, if the value we want to find out, if you calculate, then it is going, you are going to get 16. Yes or no? You are going to get 16. So basically in this population, how you can find out the decoded value, I think it's clear. Now for representing a control optimization for this kind of problem, you can take usually say 4n variables for the fast convergence. You can say n is given by the number of control variables. If n is 1, then you can take say 4 strings. So I have taken 4 strings here for the population. What I am telling you, you have to take for fast convergence. This rule is given that 4n variables, 4n strings you can take. If you are having n is equal to 1 control variable, then you are going to take 4 strings. So therefore, I am taking 4 strings here in this population. This is called as initialization. So first process is you have to get the decoded value. Randomly I have selected this string, first, second, okay, third, and then fourth. So पहला काम क्या है? The first process is that you have to obtain its decoded value. The first string is having decoded value is 16, second is having 2, third one is 6, and last one is 1. Am I clear to everybody?
येस सर
See, I am going to tease you throughout of this basically this FDP because you must get it. Basically, once you get it, then you will be able to start working on this kind of any kind of optimization problem. So that is my objective for today's session. That you must start. So now the first process is over. Decoded variable we have obtained. Now the formula which I derived, that this formula pi minus 0 upon 2 to the power 5 minus 1. For the first string, that if I put it, say that decoded value here 16, this is the x minimum, then you are going to get 16 pi upon 30. If you calculate, then you are going to get 1.62. This is the value of x. Now see how I have converted that binary string into a real number. Is it clear to everybody how we can represent that binary string into a real number? And that is basically all the times you will see that that value will lie between 0 to pi. The second value, if I put it say here 2, then you are going to get 0.2026. Second value. Second value of x. Similar way, if I put 6 in place of decoded value, then we will get 0.60x. Another value, if I put say 1, then we are going to get this value. So now we have obtained this first values of control variable. Now we have to see whether this x is between 0 to pi. Yes, it is always you are going to get uh, between that limit. Why? Let me tell you this thing. The value of decoded variable here, pi minus 0.31. So if I observe this pi by 31 into decoded variable, this value decoded variable, it is we are going to change based on the binary string. ये value जो है it is going to change from say decoded value based on the binary string, and always you are going to get the value between 0 to pi. Yes or no? Am I clear to everybody? The decoded variable it is from say 0 to जो decimal value आएगा it is from 0 to 31. So 31 max value 31 by 31 pi. It means the max value you are going to get pi. The minimum value you are going to get if I put decoded variable is equal to 0, then it's a 0. So you are going to all the time the values in the given, it is going to satisfy that constraint. That is why that is the specialty of this uh, binary coded GLS. All the times you are going to get the control variables within limit. Now in the second process, once you have evaluated the x, then what is next process? We have to evaluate f of x. X आ गया, then our second process is to find out f of x. F of x is, it means sin of x. Now for the first value if you calculate, then you will get 0.9987, second 0.20129, third 0.5712, last 0.1011. These four values you are going to get. Now can you tell me which value you are getting the highest value for this solution out of these four? First one, yes or no?
First one,
0.99. Yes,
0.99,
yes, 0.9987. And what is second? Second one, 0.5716.
0.57.
Is it visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay, okay. Then you can see that the first solution is best solution. You can give now this optimization problem. Basically, what you can do, you can assign the fitness. The next process is giving the fitness. So which basically it's a maximization problem. So for this maximization problem, you are getting which value is best? 0.9987. That is first. For the first string, you are going to get best value.
आता माझी गरज नाही राहिली राहण्यासाठी
And then third point, it is best. So you can make the order first, second,
ट्रेन
third,
झालेला
fourth,
आता सर्टिफिकेट
and
वाटायचं
based on that,
सही कोणाची
if you calculate the average
यांची करून पाठवा
of
मला
all these values, ये चार values निकाला है आपने 0.9987, 0.20129. Now then you have to take the average of it. Then you are going to get, if you calculate the average, then you are going to get 0.46810. This is the average for the first iteration. Then it is next step. What we have to calculate? fi upon fi, f of average. It means what? जो भी फर्स्ट वैल्यू है 0.9987, उसको डिवाइड कर दो f average. Then you are going to get this value. If you are having calculator, please do it. 0.99871 divided by 0.46705. Then you will get 2.1335. Can you check it? Please do it. If I am wrong somewhere, then we can correct it. What I am telling you, you have to divide the first 0.99871 divided by the average value 0.46810. You will get 2.1335. Is it coming? Please tell me yes or no.
Yes, sir.
Yes, sir.
Okay. It means it is
Yes, sir.
coming correct. Then it means basically this part, last part, Fi upon Fi average. This is nothing but a kind of finding fitness. Fitness, it is called as finding the fitness. So you will observe that the fitness value for the first value is 2.1335. For the second value, if you calculate, then it will come 0.4300. Third value, if you calculate, then it will come 1.222. Fourth point, if you calculate, it will come 0.216. I think up to the finding the fitness, the thing is clear. It means first is over representing a solution. Second one is also clear. That is, we are going to assign the fitness. Assigning fitness. Now after this, basically once you uh, find out based on this population, initial population, this is called as population, initial population, initial population. How many strings are there? 4. ये अपने को ध्यान रखना. We have to keep in mind that this population basically it should not change. The population, the next iteration also. So it's the first iteration. So we have obtained say this value as best. Okay, that you have to keep in mind. So ultimately, what is optimization when you find out say optimization curve? What I mean to say by convergence curve? You can see if I plot, here the number of iterations, number of iterations, okay, and here is your objective function, say f of x. Here f of x is sin of x. Say if you find out the solution, then in first iteration you will get say some value, and then in second iteration, this is the first iteration. Second iteration, say you will get some value. If it is minimum one, then say this value. Okay. In the third iteration, if you don't get the better value, suppose then you have to retain the previous best value. Say this value, f of x1, and this is for the first iteration, and this is for the second iteration. Then you are going to get this kind of optimization curve, like this. Okay. So this is what I told you about minimization. But if you take a maximization problem, so then you will get some best value here, then you will get some best value. If you don't get it, there is no change in the. If you don't get the best value in the next iteration, then it will remain constant. Then like this. Okay. So this type of curve you are going to get it for say minimization problem. This type of curve you are going to get it for say maximization problem. Am I clear to everybody?
Yes, sir. Sir.
Okay.
Yes, sir.
In the next step, uh, we will start from basically uh, that fitness. The fitness निकाला था हमने 2.1335. Again, I will take the continue the table. Yeah. Okay. Fi upon Fi. These were the 4 values which we obtained in the last iteration. Okay. Fi upon Fi. Now what you have to do in the next step? There is an basically an operator is called as crossover. In this string, basically, what we have to do based on the natural genetics, we can exchange the position of some particular strings. and we will take basically maybe say which is the best solution. We will take the copies of that. So you can see that first solution were best 2.1335 and third one, first one and third one. So what I will do, I will take two copies of that. And third solution is also is best just below 2 after the first one. So I will again take the two strings. Am I clear to everybody? I will take in the mating pool. I'm going to have the mating pool. There will be competition between this four string. But what I will do, I will not take the bad values. I will take the good values. What I mean to say by good values, best fit values. So what I will do, I will take the copies of that. So what I will do, I will take the first one, the first best solution, that is this one, and I will take two copies. Say randomly I have distributed here. I am going to take two copies, one and two. पहला जो solution था, first solution, 10016. I am going to have the two copies of that. And third one, third value, third string, 00110. I am going to take two copies. So here you can see the first and last one. Say I have taken the 10000, and between these two, the copies of the third string I have taken. So what I have done here, is there anybody who can tell me? I have just what I have done, that I have taken the two copies of best and another best two copies. So there are, I have retained the population is equal to 4 strings. I am not going to change it. And this is called as the mating, mating pool you can. And what is AC? AC is nothing but the actual count of strings in the population. पहला जो solution था, it was best, and third solution were at the second position. So I have taken the two copies. Is it clear to everybody?
Yes, sir.
Okay. Now after this operation, what I will do, now the another operation is known as crossover. What I will do, I will change the position. So I will take say first string. Let me copy it. Okay. Okay. Crossover type. Crossover type, it means what? See, I have written here say 3 and 3. It means if I take this two string, first two string, after third bit, I am going to change the bits to the another string. If you exchange now here you can see one dash line is there. Basically after third bit, here 00, and the second string you are having 10. So what I am going to do, this 10 will be swapped to the first string. Now this string will become 10010. Okay, and second string 001. यहाँ तक it is going to retain that information, and then you will get swapped to the 00 value. Yes or no? It is clear to you? We will obtain this string. If you are not getting, please tell me in between, because you must get it. If then only you will be able to start working on this genetic algorithm. Is it clear to everybody? I think
Yes,
no
sir.
reply. Okay, okay. After third bit, we have to, the last two bits we have to swap. Then you will get the first string and then second. अब जो नीचे वाला string है, last two string, this one and this one. Why we are doing this crossover? Basically to change the solution. Basically we want to search the space, and that is this type of mechanism is available, that if you swap maybe there is another operator, maybe a mutation operator is managed, or maybe there is a crossover operation. It can be performed. Here I have taken randomly the third bit. You can, after the third bit, you can change the positions of strings, and in the last two strings, here I am taking after two bits, you exchange the position. So here you can see one dash line 00110. Last three bits will be get swapped with these values. So then you will have here first two bits will be 00, and the last bit will become 000. Is it clear to everybody?
Yes, sir.
And then for the last string, after two bits we will retain, and then it will, the last three bits will be replaced by this 110. Okay, then you will have. So here what you are going to observe, that we have exchanged the position to this crossover. So that randomly you can select after maybe say single, it is known as single point crossover. Maybe you can say select two times the crossover for these strings, that may be called as the double two point crossover. So here I am using single point crossover. After third bit and after second bit I am exchanging the position. So what is the advantage or disadvantage, you are going to observe it. Say for the decoded value, now again you have to find out the decoded value. If I observe the first string 10010, so the decoded value will be 18. Now the new value will be 18. 18, ये वाला जो स्ट्रिंग है इसका वैल्यू निकालो मैं, तो इट इज 18. सेकेंड स्ट्रिंग, if you calculate the decoded value, then it is 4. Third string, if you calculate the decoded value, it is 0. Last string is 20. Okay. Then after this, what we have to do? Again, we have to find out x by that formula, what I told you. If I put it, say, decoded value is equal to, say here in the formula, pi by 31 into dv. That decoded value we have to put and obtain the control variable, set of control variables. So then if you find out control variables, the first control variable कितना है 1.82415. If you calculate, just take first value. How you are going to check? Pi upon 31. Pi upon 31 into decoded value. Here in the first case, pi upon 31 into 18. Okay. Let me just check. You can also check in the calculator. Pi divided by 13 is equal to this value, and then you multiply it equal to 18. Sorry, 18. So then you are going to get 1.8241. Okay. Am I clear to everybody?
Yes, sir.
Yes,
Okay.
sir. Okay, sir.
Yes. Then for the second string also you can calculate this x. Third string also you can calculate x. For the last value also you can check x. Now again what we have to do, we have to put it to the objective function. Basically our objective is to find out the maximum or maximum value of the objective function. Then if I put these values in the objective function, then we will get 0.96807, the second value 0.39434, and then 0, and then last value will be 0.7907. Now again what we have to do, we have to obtain the average. Now here you can see the average value. If you compare with respect to the previous iteration, earlier time it was having the value 0.468105. Okay, average value. ये वाला green. Okay, 0.468105. Now it is improved F average 0.53828. But the base value is here what we are obtaining. In the last iteration it was something 0.99, 0.9 I think it was 0.99871. Now it is the best value. All the times we have to keep the best value or the best value we have to retain. So here this is how you can obtain the f of x by using genetical area. This operation I think now is it clear to you everybody? This process will be repetitively for the number of iterations we will have to go through depending on the objective function and its convergence. So then you are going to obtain the convergence curve. Convergence curve, it means what? With respect to the number of iteration, how your solution is converging to the maximum value. इधर आ जाएगा iteration, number of iteration, and here you will get the f of x. Here the objective function you have to get the maximum value. So what value in first iteration, second, third? Say I have taken 1000 iterations. So then up to 1000 iteration, how you are getting the curve? That is nothing but is called as the convergence. Am I clear to everybody?
Yes, sir.
Okay. This is nothing but the mechanism for working with your genetic algorithm. I think the process is clear to you. But other than that, some other parameters are also used. Maybe say the crossover, but I have used here. The importance I have told you that how we can crossover. Also, there is one phenomena is called as say the methodology is used, that is roulette wheel selection. In this, basically, in there based on the table number one, you can see there table number one जो अपन ने निकाला था table one, this table. Okay, here थोड़ा कॉपी कर लेते, just copy and here. So that you will understand the mechanism. Some part I have taken from table 1, the value of x. Here you can see the values. Okay, first value, second value, third value, and fourth value. First, second, third, fourth. Here also you can use some roulette wheel selection for finding out the fitness. The f of x you can calculate, you will get these values. Here what you have to do, you don't have to find out the average, just find out the summation. सभी values को add कर दो of the objective function. You have to find out the objective function, and then you have to add all these values what we have obtained for the course thing. Okay, this is f of x, summation of f of x. Then what we have to do in the second step, we have to find out the probability of ith solution. Probability of ith solution, it means probability of first string, probability of second, third, and fourth. If you observe, it is expressed as f of x upon summation of f of x. Ith value, it means first value same. What we have to do? First value was 0.99871 divided by the summation of f of x. So what I mean to say here, what I mean to say, 0.99871 divided by summation. Summation is what? 1.875. to fourth. Then you are going to get probability of first string. Similarly, you can get second string probability, third string, and fourth. So here, if you observe, you are going to get 0.533, 0.10, 0.305, and then 0.05. Here also you can see if you can use another scheme that is called as roulette wheel scheme. We can obtain the probability to find out the fitness. Here you can see the probability of occurrence. The probability is of first string is good. First and third जो अपन ने निकाला था पहले फर्स्ट और थर्ड वाला string. So this is another type of methodology it can be used for finding out the fitness. Is it clear to everybody?
Yes, sir.
Either way you can use the first one or say this. You can take the help of this also.
Samjha ka?
Yes. Crossover operation, I have told you that single point crossover you can use it, or double point. Okay, the double point crossover also you can use it. Like say if you have some string and at two places. Say here I have shown through. Let me take it to that slide where I can highlight it and then you can understand it. Single point crossover I have explained. The double point crossover. What we can do, say here I have mentioned two lines here and here. Okay, this green line. The first string, first 10, it will be written between the two digits. Earlier it was 00. Now it is shifted. The exchange with the second string. ये जो 11 था ये ऊपर शिफ्ट होगा, इसको इधर ले लिया सर और इधर 00 आ गया. Okay, and last bit also 0 and 1 they are exchanged, so it is known as double point crossover. So sometimes depending on the basically whether we are getting the good solutions or not, so for searching out the space throughout space basically we have to use this technique. I think the roulette wheel and this double point crossover is also clear, this terminology. Hmm? Yes or no? Please tell me yes or no whether you have.
Ye- Yes, sir.
We are going to exchange the position, maybe at single point or say double point. Then another scheme is called as the mutation operator. Mutation operation. Mutation, it means what? If suppose you are having uh, some string set, let us say if you have say this string, this string. What we can do with this mutation operation, basically we can change a single bit also. Here you can see that this string, the last bit basically 000 is there for all these things. What we can do, we can flip it 0 to 1 for finding out the best solution. 0 का 1 कर सकते हैं. It is based on some particular random simulation. What we can do, that random simulation, we can generate a random number between 0 and 1. If suppose that random number what we have generated in the calculator also we can generate this random number. If you have calculator, then there one command is given RAN. So that always you are going to get the value of that value is between 0 to 1. That is a kind of uniformly distributed random number. If that random number is greater than 0.5, then split the bit 0 to 1. Okay, if it is not there, then don't change it.
Yes, sir.
So this type of strategy also we can use it. See, all these things what we are doing is finding out the best solution. And then you can see usually the flow chart. If you see academic audit, then We have to start and we have to initialize the population, which condition we are taking, solution of objective function, and then assigning the fitness value, then finding out the condition. Condition may be whether you are getting the prediction or not. If it is not, then we have to apply say, the reproduction. Again, the solid population will be generated. It will go through the crossover. It will go through the mutation, and then increase the generation. Again, evaluate the objective function. This process will be repeated till you are not going to get the optimal solution. So this type of process basically is used for the optimization function. And please, I will tell you that this kind of meta heuristic optimization technique also they some of the techniques they are called as evolutionary techniques, based on the natural genetics like this binary coded DNA has its own mechanism to serve to the global optimum instead of local optimum. Is it clear to everybody?
Yes, sir.
Yes, sir.
Okay. So this is nothing but all about the genetic algorithm. This is all about the genetic algorithm you can take. Now, what you can do for applying this particular methodology for a particular function. So can you do it for finding out say your uh, this problem? Let me the maximum power transfer theorem. Hmm? Can we apply the solution? Actually, we know it that you will going to get RL is equal to RTH, and then also you are going to get that for maximum power value, that you can get it. So can you find out by using this methodology which element you are going to take as control variable? Hmm? Which value you are going to take as control variable? Can you tell me? Suppose this methodology what we have used, we want to apply it for say this this part. This is also an optimization problem. Hmm? Although we know the solution, but by using this method, in how many iterations we get the solution, that we can do it. Yes or no?
Yes, sir.
Yes, sir.
So what is the objective function here? This value. It is objective function. This is objective function. Here you can take say the value of voltage. VTH is equal to say 100 volts. RTH is equal to say 100 ohm. RL is variable from say 0 to 1000 ohm. Okay. So which part is variable for this objective function? RL. Otherwise all parameters VTH and RTH they are fixed. So RL is variable. So I can take RL as control variable. Control variable. And then we will use that formula. Formula कौन सा था? Xi minimum, X minimum plus X maximum minus X minimum upon 2 to the power Li minus 1, and this whole part will get multiplied with the coded value. Am I clear to everybody? This formula you can use it. Say I give what is the range for RL? What is X minimum, X maximum? RL का मिनिमम कितना वैल्यू है? 0. RL मैक्स कितना है? 1000.
1000.
Yes, this value you can take. So X minimum here you can generate the sample. X minimum is 0, X max this 1000 ohm L of I string, say 5 bits, like the earlier problem we have assumed. There we can use say 5 bits uh, to represent this control variable, and say we will take say 4 strings. So 4 strings, and you have to generate same process you can apply for obtaining the maximum value. And then you can observe here, if you calculate the maximum value, then you are going to get approximately for this, uh, as you know the condition that RL is equal to RTH, and the voltage as the maximum power condition, so it is nothing but half. So almost 50 square, as the supply voltage is 100, so 50 square divided by 100, 50 into 50 upon 100, okay, 25. Am I clear to everybody? Now we know the solution, but we want to prove it whether we get the solution by this technique or not. So then we can apply it. Is it clear to everybody?
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
So actually you can use this process known as genetic algorithm, one of the evolutionary techniques or the meta-heuristic technique. Similar way you can have the number of techniques like random search, hmm, random search method, evolutionary strategy method. There are so many methods, but depending on this method, maybe one of the technique may be best fitted for some kind of problems and not suitable for the other kind of problems. But then you have to keep on this kind of optimize. You have to use this kind of optimization process. So I think now it's over about the various one of the technique I have taken to explain you about the optimization. So there are the n number of optimization problems, maybe for not related to electrical engineering. Everywhere there is a problem of maximization or minimization. Maybe field of mechanical or say electrical. In electrical also you can have the power losses minimization, harmonic minimization. Hmm? Maybe fundamental component, this supply voltage in supply voltage. See, actually, the recess time is there and the students are coming. Or I think so. We should stop here. So if you have any doubts, or you can ask Ritik. Is it clear to everybody the things which I told you?
Yes, sir.
Yes, sir.
So this basically one of the technique genetic algorithm. You can use it for finding out the optimal solution. So first of all, you must understand what is the optimization problem, and then what are the constraints. So anywhere, if you want to optimize it, say for any, maybe for the today's scenario, the electric vehicle also is one of the coming technology which we are going to have the charging stations at different points in the radial distribution system. Then also there may be a kind of optimization problem. Even with your distributed generation, where to put it, where not to put it, so that we can get the optimal performance at the system, maybe the minimum power losses, the better voltage profile. Like that we can select one kind of optimization problem. Lot of literature is available. You can see the papers, and then you can use the different techniques. I think it is over, or if you have any doubt then you can ask.
तुम्हाला काही डाऊट्स असतील तर तुम्ही विचारू शकता.
If you want to start, then as I have to given you one example, that maximum power transfer theorem. यहाँ पर you can maximize the maximum power is as an objective function with by taking the control variable as load resistance. You use the genetic algorithm, find out say one iteration, two iteration, third iteration, and basically once you understand, always I please keep in mind, if you want to use any optimization technique, then first of all on paper you must be able to calculate it, what is happening, because then only you will be able to implement it on computers. Because digital computers, the MATLAB also you can make the program of a lot of flexibilities and libraries available. You can use the resources, and also there are tools in your MATLAB known as GA tool. Genetic algorithm tool is also there. C search tool, it is also there. So many things are available in that MATLAB where you can use these resources for any kind of optimization. But the question is, you must be able to formulate your problem in terms of variables, control variables, and then you have to optimize your control variables. Then you will get the optimal values of your function. I think with this you can. I think it is sufficient for today. There are so many
Yes,
techniques.
sir.
There are so many techniques, and if in future, if we get time, then physically also we can meet and have discussion on that. Hmm? Thank you all.
Thank you so much, sir, for this wonderful session. I'm sure all our participants have gained incredible knowledge and ideas from this session. As you covered many optimization problems, maximization of function, constraint optimization, unconstraint optimization, such as, and many more. So, thank you so much, sir, for this session. All participants are requested to fill the feedback form, which is sent on our WhatsApp group. Thank you once again to everyone for joining us virtually today. We look forward to stay connected at 2 p.m. for the next session of day 3. Thank you. Have a great day.
Professor Rana, can we leave?
Yes, sir. Yes, sir. Thank you, sir.
Thank you very much.
Thank
Thank you.
thank you,
Thank
sir.
you. Thank you. Very.